That could have something to do with it. Because look, it worked right here. So let me see this. Yeah, I don't know why this one didn't work. It looks like this one worked, right? So there goes my pig. Convert. Convert might not even matter. Let's see. Well, actually, I'll do this. I'll go to Exploded View, attach it here, and click on this. So what this is doing is this, right? Well, let me connect to a box, I guess, to make more sense. And I'll raise this box. See how I'm like moving it, and it's like kind of, it's taking a little bit longer than the Voronoi fracture. So I'll do this. So if I click on this, what it does is it gives me some fractures right here. And also, if I take this and connect it to this, all right, and if I go to this output, see what happens. All right, so it's breaking. Cool. Now let's adjust this some more. So we have our fracture ratio right now is at 1. If we take it lower, it's giving us less fractures. We have our fracture seed, which gives us random. It's not doing it right now. I just thought it'd give us some random values, but it's not. Scatter points. Let's look at this. Okay, so this one's more of a seed, or more of a seed that you can adjust. Now we have something called input points. All right. So let me clean all this stuff up. I'll move this like over here or something. And I'll just deal with these. All right, so this is our fracture, and this is our exploded view, all right? We have this. So we have something here called input points. So that means if I put some points in here, it'll fracture it where the points are. So let me do it again. So I'll type in a sphere, and I'll put my sphere, what am I doing? Right here. So let's say I just want some right here in the middle. And this is what I'm about, these points right here. So what I'll do is I'll right click scatter. So we have this group right here. We can do our VDB, right? From polygons. Only thing is this isn't a polygon yet. So we have to go polygon mesh. So we have this. Oh no, that's what it was. So we have the VDB, now we have this. So we have our little fog volume inside. We can adjust this, whatever. Anyway, so we have our scatter right here. Let's just make this 100. And now what we can do is, if you highlight your mouse over this, it says extra Voronoi points, Voronoi points. So we click on this. And so we have our sphere here, but we don't have the points, right? The reason why is because we have to click on this thing that says input points, right? So we have this right here. Let's click on input points because we have the points coming in now. Now, if you can see, it added points to this now. So let's check it out what our result is. So it's a bit different. Well, there's more points. All right. So let's just click off of this for now. Now this right here are like fracture levels. So it's like it gives you these fractures right here. And then it gives you some extra ones right here. So if I click off this right here, which means I'm disabling these extra fractures, is giving us these base fractures. So that's like one set of cracks right there. And then if I go to this one, this is a whole nother set. So if I increase this number, I'm getting more. So it's just like kind of two levels of fractures. And this resolution right here is kind of like I think it's like a VDB. So I think it's this right here. So this is called a Vdb Fog Volume. Now, if I increase this, it gets like bigger. I mean, I'm sorry, not that one. This right here. So the larger this number, the lower resolution it is, which is okay because it's still like point scattered. But the lower this number, the more accurate to the form it is. All right. Just like the pig head when we did it, it got more accurate. So let's look at a pig head. So if I go in this number right here, the larger I make it, the less true to the form it is. Okay. So I believe that's what's going on here. Spacebar F. All right. So now there's something called chipping. And what chipping does is it takes a few of these pieces and figures out, I guess, where like a corner piece would be. And in a simulation, actually, I'm not even sure the technical terms. I got to watch the presentation again. But let's click it and see what happens, right? Like I said, it could, depending on your computer, be some loading time. It's kind of funny because I was looking at this right here and I was thinking, all right, if that was to break, it'd probably be breaking right there, maybe a little bit right there. And it kind of did that. We did it at least on that area. So it gives you like a little piece on the ends. And you can go to this C, switch up the number where the chipping would be. And then the overall ratio. So right now it's at 5. It's kind of going down a little bit more. But if we up it, we get more chips. What does this mean? More action for our simulation in our dynamic world. Right? So another thing we can do is if we go to detail, let's look at what happens here. Click on edge detail. Like I said, depending on your computer, this will take longer or not. So let's look at this. So remember those shapes before the detail. So let's check it out. Now we have something that's kind of wavy-ish, you know, something more natural looking instead of like straight cuts. So let's look at what the cuts look like. Take this off. Now everything's like straight, linear, from point to point. Bang, 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 bang. Now it's like, ooh, okay, all right, we're moving along. We got some noise. Things are jumbled. And these settings right here are a little bit sensitive. Let's see what they do. This is a simple enough example, so we should be able to see it. But look at that one. That's real nice. It's like sharp on the ends. And let's just see what it looks like without it. See? All right, so let's take this detail size, see what happens. Let's crank it up. Now it's more linear. Control Z. Now it's sharper. So let's see what happens if we take it to half of this. Control Z. So it just made it a little bit more crazy, I guess. Let's take this noise height. Let's raise this and see what happens. Oh, look at this. I might have a crash. Oh, so look, it got super insane. Control Z. Yeah. So let's see what happens if we just take it to 2. Yeah, now look, we're getting some crazier cuts. You see? So now let's see what this looks like in the sim. All right, see what we're getting now? Some nice organic looking chunks. All right. Cool. But remember, these things add time because, let me go back here. Yeah, they added a little bit of time. So you might want to, like, if your computer's slowing down, you might want to simulate this way just to get an idea of how things work. And then later on, when you kind of like it or like whatever you're doing, then you can kind of switch to this and do things this way. Like I said, it's all on your computer if you can handle it or not. Well, we have the edge detail. Let's look at interior detail. So if I look at this and I turn off interior detail, let's see what's happening. So it's kind of like giving us some protrusion to these interfaces. And it's smart. So it's like, all right, if this one's thick, if this one's coming out, if this one's like protruding out, then this one would protrude in, I guess push in. So anyway, it knows what it's doing. It's like this one shifts, then this one switch shifting. So interior detail, if we crank that up, kind of see how crazy this is getting. And then there's the noise amplitude, which is like how bumpy I guess this thing can be. Yeah. And then we've got frequency, which controls the amount of noise. And then offset like shifts it. So it's like a giant noise cloud, and then it's like moving to the left or to the right, depending on this, up and down kind of thing. But the cool thing is we have our shapes that don't look like, choppy blocks. And then constraints is something else. This is how we keep our it's like a force, like a glue that keeps everything together. And I'll probably go into that a bit more in the next class. But let's see what we're looking at now. So we have this right here, press play. Okay. Pretty cool.